Welcome to Học Tiếng Anh với Joseph, where we build vocabulary and practice pronunciation through reading. We continue to the very end of the book The Cat in the Box, A History of Science in 100 Experiments. Today's episode is entitled Experiment 101. In February 2016, a large team of scientists reported the results of an experiment that is so beautifully encapsulates Feynman's description of the scientific method that it deserves to be known as Experiment 101, in the same way that basic university courses are often called, for example, Physics 101. The computation in this case comes from the general theory of relativity, which tells us that massive objects orbiting one another in space should produce ripples in space itself, gravitational waves that spread out across the universe. We already had evidence that such waves exist from studies of objects shown as binary pulsars, but if they could be detected directly in experiments here on Earth, then that would give us a new way of looking at the universe. The way to do this, as Feynman would have said, the way to test the law, involves building a detector with two arms at right angles to one another made of evacuated tubes in which laser beams could travel 2.5 miles or 4 kilometers down the tube, bounce off a reflecting surface attached to a very heavy mass suspended from a system of pendulums, and then back down the tube to be combined with other laser beam. The system was set up with exquisite precision, shielded from outside disturbances, with two laser beams marching in step, actually exactly out of step, so that when combined, they exactly cancel each other out. The prediction, Feynman's guess, was that a gravitational wave passing through this experiment would stretch and squeeze the two right-angle beams in different ways, so that the lasers got out of step and produced a flicker of activity in the detectors where they combined. The calculation using the general theory of relativity predicted exactly what kind of pattern would be produced. And on September 14, 2015, exactly that pattern was seen in a pulse lasting just under 1/10 of a second, corresponding to a change in the length of the laser beams of less than the diameter of an atom. Even better, the pulse was seen in two identical detectors, one on each side of the North American continent, with a delay of just 6.9 milliseconds between its arrival at the first detector and its arrival at the second detector. This confirmed that it was real and that it traveled at the speed of light. The exact pattern of ripples in the pulse matches the predictions for the collision and merger of two black holes, each with about 30 times the mass of our Sun. In the process, about 3 times the mass of our Sun was converted into energy in the form of gravitational waves, in line with Einstein's famous equation E=mc². This enormous outburst of energy from a source estimated as being slightly more than 1 billion light years away was able to shake detectors on Earth by a tiny amount. This astonishing experimental result was a culmination of more than 2,000 years of experimental science, and it all began with another kind of wave, ripples in the bathtub of a Greek philosopher called Archimedes. To our vocabulary section, encapsulate, computation, orbiting, gravitational waves, evacuated tubes, pendulums, culmination, ripples in the bathtub, Archimedes, and yay, the end of the book. Thank you for sticking with me, and I hope you enjoyed it. We will see you in the next book very soon. Bye.